Okay, so in this set, we have four cars that need to travel from A to B. Two routes are available via M and N. Okay, so I have A to B, M and N. The roads from A to M and from N to B are both short and narrow. Okay, so let me get a little bit more information first. I know I have to draw a sort of a network diagram, but just I'm thinking what sort of other information I have. In each case, the car that takes 6 minutes to cover the distance, and each additional car increases the travel time per car by 3 minutes because of congestion. Okay, so this is for the short and narrow thing. So let me draw a small network here. So we have A and B. These are the two points, end points, sort of. N and M are via roads. So we have one road like this and one road like this. So these are the two connections that we have. In each case, so this is for A to M and N to B. So these are the narrow ones or something. And we have 6 minutes. So one car takes 6 minutes to cover the distance. And there were a total of four cars, right? Okay. So 6 minutes to cover the distance, and each additional car increases the travel time by 3 minutes. So let me mark it in this way. So there is 6 minutes for the first car, and for each additional car, we have something like this. So this is for 1 plus n or something. So if I have one car, it's simply n is 0. So in that case, I'll take 6 plus 3n, and same thing for over and above that. So same thing for n to b as well. So I have 6 plus 3n. So this is the time. Okay. Now, okay. So for example, if two cars drive, yeah. So this was understood anyhow. So if two cars are driving from A to M, each car will take 9 minutes. So this is okay. So yeah. So that is relevant. Yeah. But I understood that anyhow. So for each car, this time would be 6 plus 3, and that was mentioned earlier as well. Each additional car increases the travel time per car by 3 minutes. Okay, anyhow, on the road from A to N, one car takes 20 minutes, and each additional car increases the travel time per car by 1 minute. Okay, so this is also for 1 plus n, so I can mark this, I guess. For M to B, 20 minutes each. Yeah, so it's same for M to B as well. So first of all, for A to N, so we have 20 plus n. Right. So these are the timings. And for M to B, we have 20 plus, let me write this a bit properly, 20 plus 0.9n. Okay, so these are the timings. Now, the police department orders each car to take a particular route in such a manner that it is not possible for any car to reduce its travel time by not following the order. Okay, that's something to understand. While the other cars are following the order. So what does that mean? The police department orders each car to take a particular route in such a manner that it is not possible for any car to reduce its travel time by not following the order. Okay, so indirectly, this statement is telling me the police department will place the order in a way that itself will reduce the travel time of the cars, because that's what it says, that it is not possible for any car to reduce its time by not following the order. So had that been possible, they would have broken the order or something like that. But then the police department are ordering in a way so that the time taken by each car is minimal. Okay, so that makes sense somehow. So while the other cars are following the order, so I think there will be something related to time traveled or something. I mean, there are a total of four cars after all. So let me get to the questions now. Okay, so five. How many cars would be asked to take the route A and B? That is Akala, Nanur, Bakala. by police. Yeah, so that was it. So I have to think about minimizing the time. So let's go car by car. So there are four cars. We have to, I believe, think in that way only. Even question six, what does it say? All cars follow the police order. What is the difference in travel time between a car? So it's the same question basically, no change in premise. So yeah, so four cars we have. The first car. The first car can ideally take either of the routes, right? So if I talk about car one, it can go either through A, M, B, or it could go via A and B. In whichever case, the total time will be the 6 plus 20, right? Either here 6 plus 20 or here we have 6 plus 20. So it doesn't really matter. So car one, I think I can just randomly allocate. So let me allocate it to A and B. So that would take what? In the next question, I have something related to time. So let's do the time also as we go along. So this is 26 minutes. Okay. Now car two, once the car 2 starts traveling, now where does car 2 go? Obviously, now the police will not order car 2 to go via AMB because, as we already discussed, uh, the police itself will try to reduce the time for the car. So the car 2 should be, because we assume that car 1 is via AMB, that didn't matter. So in this case, car 2 will be asked to go via A and B. So in that case, when car 2 goes via A and B, so that's also another 26 minutes. Great. Now, what about car three? So, if you consider car three here, so car three, now this is something we have to understand. So, whichever route car three takes, whether A and B or A and B, it will be the second car in that route. Right. And as soon as we hit n, this 1 plus n as something more than one, so essentially two cars are going. So that is going to what I mean is increase the time for both the cars that are traveling in that route. So essentially, what I can say is car three should be the second car on this route. It's very obvious. I can look at the numbers here. If you check this out, this is 6 plus 3n, and here also we have 6 plus 3n. So no disparity as such in these two cases. Only disparity happens between these two, right? So here we have 20 plus n, and here we have 20 plus 0.9n. So essentially, that is really increasing the time. Now we can directly, I mean, this n was irrelevant here. I just wanted to keep that information to understand later on. So what I can directly see is because of this car 3, once it starts taking, so obviously the car 3 will go via A and B. So once the car 3 travels via A and B, the car three's time is 26 minutes plus 3.9 minutes. And even this car one's time increases by 3.9 minutes. So effectively, both the cars' time has to increase. So this is the second car on A and B. Now, the fourth car. Now, this is pretty obvious. The fourth car must be taking A and B, right? Because if we if we send this car 4 via A and B, in that case, the car 4, the car 3, the car 1, each will be, I mean, even in car one's case, 3.9 minutes will add. In this case, 3.9 minutes will add. So in each cases, we'll have an additional 3.9 minutes. So that will be an overload, right? I hope you understood that. So let me explain this once more. So suppose I send car 4 via this A and B. In that case, car 4 will be 26 plus 3.9 plus another 3.9 because there are three cars now. And here also it will be 3.9. And here also it will be 3.9. But if I send it via A and B, so that is what I should typically do. I should ideally do that. So if I, let's say, just 1 second, car 4 via A and B, in that case, the increase here is, although the increase here is more, A and B is, in this case, it is 4 minutes. So 1 minute here and 3 minutes here. So there's 4 minutes, but we don't have now. I hope you can notice in that case, we were getting 3.9 plus 3.9 and also 3.9 increase of two different cars. But in this case, we'll just increase this time by 4 minutes. So this is the first structure. So for 5 and 6, now we can answer. 5 is asking for how many cars would be. So either route is 2 cars. So this is also 2 cars. That is the answer. And question number 6 is asking if all the cars follow the police order, what is the difference in time between a car which takes the route A and B and a car that takes the route A and B. So we can choose any one car. So one car is having a difference of from here itself, right? 0.1 minutes. The first 26 minutes is anyhow not a differentiating factor. So that is option B. So this is for the first 2 questions. So let's take the next ones now. So this question is saying that a new one-way road is built from M to N. So now there's a connection from M to N. I should have given directions earlier. I didn't do that because that was not required. Let me do that now. So these are the directions in which the travel is happening. So M to N is the direction here. So there's the road is built from M to N. Each car now has 3 possible routes. A, M, B, A, and B, or A, M, and B. Yeah, that is pretty obvious. So either you can go directly via the earlier 2 routes that we had, A and B or A and B. And now there is an additional one. You can go A, M, N, B. So something like this. Great. So this is there. Now on the road M to N. Okay, this is interesting because something that is that I noticed right now. I'll come to this information later on, but this is something I tried. So let me revisit it. So something like if there's a car which is going via AMB, that car is traveling on AM, and even if a car is going via AMNB, even that car is traveling via AM. So this increase thing will affect these 2 cars, but it won't increase the time of this car here, or let's say this car here. So that has to be taken into consideration, I believe. So let us go ahead here. So now, yeah, so on the road M to N, one car takes 7 minutes and each additional car increases the time by 1 minute. So that is similar to what we had earlier. So 7 plus 1, and let me write that explicitly anyhow. So we have 7 plus 1 and for this part, right? Great. So assume that any car taking the AM and B route travels the AM portion. Yeah, so this is what I was talking about anyhow. At the same time as the other cars taking the AMB route, and the NB portion at the same time the other cars going via AMB route. Okay, great. Yeah, even that is shared with A and B, right? I mean, something like this. So if there is a car, let's say traveling via AM and B, and one car via A and B. So there are 2 cars here, but there's just one car here and one car here and one car here. So something like that. This is an interesting one. Should I mean, interesting in nature, but should take some doing here. Okay, let's get back now. How many cars would the police department order to take the AM and B route so that it is not possible for any car to do? So same thing. Assume the police department would never order all the cars to. Okay, so assume that the police department would never order all the cars to take the same route. Okay, maybe that is relevant. So let's check this out. So first of all, let me write down the routes in this case. I can go car wise. Okay, let me go car wise only. So let's say car 1, car 2, car 3, and car 4. So the first car that I would check, I would simply ignore the n's because for the first car, this is 1, so n is 0. So that doesn't matter. So the first car, which one is effective? So I knew earlier that AMB or ANB doesn't matter. So for the first car, I'll obviously put it on AMNB because if you check, I was just calculating this part mentally. So this is 6, this is 7, and this is 6. So if somebody takes this AMNB route, so that car would take 6 plus 7 plus 6, and that is much less than 26 minutes, right? So the first car should go via this AMNB route. So let me write that down. So this will go via AMNB, and that will take 26 minutes. Okay, so let me write 26 only. So 26, sorry, 19 minutes, my bad. So I somehow wrote the other one. Anyhow, so 19 minutes for the first car. Now the second car. Now where does the second car go? Okay, so let me analyze in 2 cases here. I have to take cases, I believe. Um, if I send the second car, I have broadly speaking two choices. One choice is either AMNB itself, or it would be via AMB, because I'm choosing AMB or ANB actually. I mean, this is the first car that will go via MB, right? So let me visually represent this. So if the car goes AMNB, one car is definitely going AMNB. Anyhow, we know that. If there is another car that goes via AMNB, so if there is another car on this route, then there is an increase of 3 plus 1 plus 3. So that is 7 minutes for each car. Okay. So that would increase 7 minutes for this car as well as 7 minutes for this car, over and above 19 minutes for AMNB of anyhow. So that is the base value that we have, something like that. So this would be the car, this would be the time for the first two cars. And in this case, okay, now what about the second possibility? So if I check AMB, now this is interesting. If the AMNB is traveling, the first car is anyhow traveling via AMNB. If the second car goes via AMB, now first let me write the base value. So if this car AMB is traveling via AMB, sorry, if this second car is traveling via AMB, so that is 26 minutes, the base value. Now what are the increases for this car? There is an increase of 3 minutes only, because only the AM route is shared. But for the first car, now this is pretty obvious. I can see that. For the first car, it will also increase by 3 minutes. It's the same thing, because for the first car also the AM route is the only one which is shared. But now I hope everybody can see this. For the second car, if you choose via AMB route, so that is like an overall increase in time of all the cars combined. It's an increase of 32 minutes. But in this case, there is like 19 plus 7, 26 plus 7. So that is 33 minutes. So second car should be going via AMB. So this is now understood. So the second car, we should choose AMB. And once we do that, I think we can handle one thing straight away, but I'll come to this. I just remembered something. So let me write this for you guys. So AMB, this is 26 minutes, the base value. There's an increase of 3 minutes and an increase of 3 minutes for both of these cars, because the AM route is shared. So there's 3 minutes additionally. So yeah, the thing I was talking about, this came to my mind. So this bracket thing is useless now. So I assume that police department would never order all the cars to take the same route. This is anyhow useless now, because these two cars are anyhow on different routes. Now, even if the next, all the remaining cars are either on AMNB or AMB, so I don't care. And all the cars are not going by the same route. Okay, let's get to the next car. So car 3. Now car 3 again, the car 3 obviously should not take AMB, because if car 3 takes AMB again, there will be too much increases, because AM will be now 3 cars. I mean, I think you can visualize this mentally. If not, just let me point this out. So the base value is 26. The AM is shared across all these 3. So that will increase by 3. So for the first, this is a one increase 3. This one has 3. This one has 3. And also the MB route. So this MB route, there are 2 cars moving, these 2 cars, right? So the MB route will increase 0.9 and 0.9. So there's too much increase. So I should not be considering AMB anyhow. So broadly, I have 2 options. So this was the scenario. Again, as in previous one, I have 2 scenarios. Either I pick up AMNB or I pick up ANB. So let me write that on that side only again. So let's pick up these 2 routes, AMNB and ANB. These are the 2 possibilities. So AMNB is, okay, so the base value in this case, so for car 3, so let me write a bit below, sorry for this. So this is for car 3 choice. Just understand that, I believe. So car 3, the base value, if goes via AMNB, so that's 676. So that is 19 minutes. So that is the base value. Now, what are the shared routes? If you think about the routes, so I'm just looking at the names. If you have this practice, this becomes easy, because AM, AM, AM. I hope you can see that. So AM, this increases. This will be the same problem as with the AMB. So I can neglect this anyhow. But let me check this a little bit. So plus three. Yeah. So this is going to be too many increases. Even this MN will be shared here. So that will be another what MN is one. So plus one plus one. So that is too many increases. So I can neglect this case. I can straight away go to A and B. A and B should be less increases. We can compare this also. So let's get to A and B now. Okay, so A and B. So what are the shared roots? What's the base value? A and B, the base value is 20 plus 6, so that is 26. So let me quickly write that 26 here. And what are the increases? So I can check by the name. So for this car, there is no AM route. So that is the advantage. So only NB is shared. Only NB is shared between this car and this car, right? So if you look at A and B, NB route, now there are two cars moving. So that's additional increase of 3 here and a 3 here. Great. So that's it, I believe. Nothing more. So yeah. So this will be obviously effective, right? So this is what I was thinking. And the fourth one. Now this is interesting. Now, if the fourth one I send either via AMB or ANB, the base value itself is pretty high. That itself is 26, right? So if I leave that out, if I neglect that case straight away, let me try and take a judgment call here. Let me see what is the increases here. So if I choose the AM and B, the reason I neglected this AMB and ANB thing, I hope you understood. Because first of all, the base value itself is 26 for each of the cases. Plus there will be everything additional here, as well as this AM route is shared with this NB route is shared with this, either of these, whichever we pick up. So that is definitely not the best way to go about it. We can verify this. I think we can see this directly after this. So let's choose AMNB and let's see what happens. So first of all, the AM route. So AM route, there is one additional car. So for each of these cars who are going via AM route, okay, first of all, the base value is 19. So there is one additional car on AM that will increase 3 minutes for each of these cars. So that is plus 3 here, not here, plus 3 here, and plus 3 here. Okay. Now, what about the MN thing? Now, MN is anyhow on two cars are anyhow moving, right? But one second. Sorry. I missed one important point here. AM already there are two cars that are moving, right? So this will be an additional 3 and 3 for this particular car anyhow. So yeah, so it will be something like this. Even this NB, even this NB thing, if we check, so that will increase this car time by another 3. So let me explain what I'm doing. So I'm just counting the number of cars. That's it. So I'm checking how many cars are on AM. So if you want, we can just, that will be better to explain, I believe. So I'll just take everything here off. These are the additional timings. So I think this is something you can understand better. You can draw a fish after this point. So this was a little something to do. I initially mentioned this. So these are the base values. Check how many cars are via AM. So there are 3 cars, right? So for each of these 3 cars, so you have 2 additional cars, right? So it's like 1 plus 2 more cars are moving via M. So there is 6 minutes for this, 6 minutes for this, and 6 minutes for this. 2 additional cars. So we have 6 minutes extra. If you look at the MN route, so these two are the MN route, there is one additional car. So that is 1 minute extra here and 1 minute extra here. And finally, if you look at the NB route, so this is NB, this is NB, this is NB. So that's another additional 3 and 3. So one car is the base value. There is 2 more cars. So that's 6 minutes extra for each of these. So 6 minutes more, 6 minutes more, and 6 minutes more. So let me verify these numbers now. So this is 20 and this is 32. This is 32. This is 32. This is 32. This is beautiful, right? Every car is now taking 32 minutes. So this matches very nicely. And obviously now you can understand that sending the fourth car via A and B or A and B would have increased this that much higher. So if you look at this particular question, it asks for uh, how many cars should the route AM and B take. So how many cars here? So that is 1 and 2. So AM and B, there are 2 cars. So this answer is 2. That is the answer for this question. Let's take the next question now. Yeah, so we have the same premise for this question as well. I hope you can read that. AM and B, 7 minutes, 1 minute extra. Now the question is asking if all the cars follow the police order, what is the minimum travel time from A to B? So every car takes 32 minutes. So the answer is 32 minutes here. You cannot have less than that anyhow. So this was the set. Okay, so this set, I would say in terms of difficulty level, if you drew the diagram very quickly, then or you understood or comprehended the meaning of this part was the most important part of the set, I believe. If you understood this part, then automatically you would be able to solve this. I wouldn't say in less time. This is something to do. So I would say this is something like. The difficulty is not very high, at least for the first 2 questions. So I'll just rate it moderate because of the first 2 questions. The third and fourth question were something to do. So I would not say this is very easy question as such. I would rate it as moderate to maybe moderate to tough or just moderate level of difficulty. And I would also say this is a bit tricky in nature because you might lose track of the number of cars that are moving from a particular route. That is something you should not. At every point, you should re-verify and stuff. So that might take a bit of time. So I would say the ideal time to solve a set like this would be somewhere in the range of 8 to 10 minutes. These kind of sets do take up time, but it is doable. 8 to 10 minutes is worth it if you can manage it, because 4 questions done in 8 to 10 minutes, that's a good time anyhow. It might stretch out to 12 minutes for certain cases, but in each of the set, as we mentioned in the initial analysis, or if you are just watching the solution, then the ideal time, by ideal time, what I mean is somebody who would be actually able to solve the set. So that is what your preparation level is supposed to be anyhow. So this is the ideal time for the set. So I believe 8 to 10 minutes is sufficient. But these kind of quantifying thing, analyzing, this is important in the set. So if you can quantify it properly, then it becomes a little simple to visualize and stuff. You can just put in you can term the total number of cars as n, but that overcomplicates stuff in certain cases. So you have to put n-1 here. So I simply try to keep it as simple as possible, so that I can visualize it easily. Because in each of the cases, whenever there is a certain number of cars on a particular route, I can just put the value as that. So let's say 3 cars on a particular route. I can just visualize this 1 plus n to be 3 and figure out the value of n, right? So accordingly, I'll take a judgment call on each of these timings. So that's it for this set. I hope you understood it. It is a nice set, by the way. CAT sets are usually nice. So thank you.